Hi, Southside Buccaneers. This is Coach Hyde again, coming back with part 2 of this STAR Science review. Again, this was something that was provided by another teacher to go along with an interactive notebook that was completed for the entire year. And we're just using this portion just to be a good review of some surface level things to kind of jog your memory of some other things that we have covered in the past couple of years in science. Now, there is be no way to do this sheet without some type of frame of reference. This is very plain on this page here. So I'm going to go ahead and help you out and talk through some of these issues that you would come across. Obviously, some things you could figure out on your own, but hey, this is what I get paid for, right? So let me help you out here. So here we have a small picture of our solar system, sun, earth, and moon. It's the designations there. And it wants us to know what this word is, revolution. A simple definition, we're just going to say goes around. So the moon goes around the earth goes around the sun. We can say the moon revolves around the earth revolves around the sun. Okay. So here we're wanting to know the time period, moon around the earth. Well, that's actually a very complicated issue, but we're going to make it simple. We're just going to say 29 days. And the earth around the sun, well, this is how we get our year. And everybody should know by this point, we have 365. We could put in that quarter, and that's why we have our leap year system, but we don't need to get that specific. So there we have the revolution box completed. Let's take a look a little closer at this rotation. Rotation, here we have the earth and the sun. Rotation, the earth spins on an axis. Okay. We've got half the earth here, half the earth is facing the sun. Well, duh, we would call that day. And on the other side that's not facing the sun, we would call that night. Well, we know the whole process for day and night is 24 hours. It takes us 24 hours to spin on our axis, or 24 hours to rotate on our axis. And we could split that up in half, 12 and 12. All pretty simple stuff. Let's take a look at these three boxes. Now, this would be impossible. Sun, earth, and moon, comparing these three spheres, but we don't know what the frame of reference is. So the designer of the sheet wanted us to identify it as spheres of gas or sphere of rocks. Well, the sun, we know that's a star, so that's going to be gas. Earth and moon, these are both rock. It's obvious on earth because we could not stand on gas. Gas would not give us a solid surface. So let's just finish this sun box and we'll go left to right. So the sun is a medium-sized star. There's no real surface to it. And it is the source of our light and heat. When we're looking at this, this is our forms of energy that we benefit from. Moving to the Earth, okay. It's a sphere of rock. It is the third planet from the sun. It's located in this area we call the Goldilocks zone. Not too hot, not too cold. Guys, there are so many specific qualities that had to take place in order for the Earth to be able to maintain life like it does. Okay. It is the only planet to support life. Okay. It has lots of things could go in this box, this area here, but we wanted to make note it has an atmosphere, which is not unique to Earth. Our atmosphere is at least unique in our solar system. Different scientists have different predictions, but another big thing we have is liquid water. I'm just going to abbreviate water, H2O. Now, water is super important. We call it the universal solvent. It is, for all intents and purposes, everything that we can figure out, a requirement of life. Let's look at the moon. The moon is a sphere of rock. It has no atmosphere. It has no life. Okay. So many days to revolve around. Well, we know it revolves around the Earth. Okay. This is coming from over here. It's the same question, just asked in a different place. Moon around the Earth, 29 days to revolve around the Earth, and we call it a natural satellite. Okay, we know that we launch satellites into outer space and they orbit the Earth. It's a man-made satellite, a human-made satellite. Natural satellites, of course, we don't make, they are natural. All right, so here we have the sun, and it wants us to list the planets in order from the sun. So we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. We have an asteroid belt. Some people think that this might have been a failed planet in between Mars and Jupiter's. Others say that it is a result of collisions between rocky bodies. Definitely some different theories there. You see that's missing here is Pluto. Pluto has been demoted to a dwarf planet. Multiple reasons for that, but basically there are other items that have been found in space the same size of Pluto or even larger that we do not consider planets. And so if we kept Pluto elevated as a planet instead of a dwarf planet, we would have to name some other bodies as planets. And also we've got some moons that are even bigger than Pluto. So it's another reason why that's taken into consideration as we're learning more about the solar system to no longer consider it a planet. So let's take a look back at the other side. Here we've got some identifications, but this is going to be an area where you can use your creative skills on here and make it nice to look at. Remember, you're going to be graded on the colorfulness. Here we've got landforms, and it wants us to figure out, based on the drawing, what is that landform. So here we've got, looks like a plateau or a flat area originally, but we have this body of water, a stream or a river that has cut a channel in between it. So this would be a canyon. We would imagine that in the past this would have been a flat ground, and based on gravity pulling water from high elevations to low elevations over the years, it has cut a channel. Here we're looking at, well, it's kind of hard to tell what are we looking at. But this is supposed to be a river, okay? And this would be the water. So we're looking at probably the ocean, and this up here would be the land. And we have this nice triangular area here. And this, it would be a delta. And it's actually not a very good drawing. It wouldn't necessarily look just like that. Moving over here on this far right hand side, this is indicating wind. Here we've got these particles. Okay. On this landform, these particles are standing for sand, and the natural processes that have the sand collect based on the wind blowing, we call these things sand dunes. What's really unique is that they all form at basically the same angle. Just some of those natural laws, the way our universe was created, the way the conditions here on Earth can make some pretty spectacular things. Okay. So here we're moving down towards the bottom part of the page, almost finished with it. Sedimentary rock. So here where they want us to moving down to some earth science, looking at rock made of, and then it wants us to tell how that rock was made. What was the process involved in order to do this? Now, for my 7th graders, you're going to get this in 8th grade science, but we will continue just on, go ahead and give you the answers for that. This is rocks made of, hold on, wait for this, sediments. Isn't that great? Sediments. Okay. Sediments are, for all intents and purposes, just layers of different materials. Okay. They get put together to form a rock. So we've got a series of processes that will make that. It's actually a lot of processes, and it's going to be hard to fit in here, but let's see what we can do. So we have surface rocks being weathered. broken down into smaller pieces, which leads to water and wind eroding. We have erosion that goes on that moves those from its original location to a new place where it is deposited. So we could call this deposition. Okay. So we got weathering, erosion, deposition. And then now it's all laying there. We get different layers. We get a compaction. The weight on top of each other start to compact these different materials. And finally, we get cementation. Cementation. So here we have, that's how we have the sedimentary rocks. Here we have wanting for the definition of fossils. Fossils, the remains of, okay, this is going to be the remains of life. Plants and animals, something that was alive that is turned into rock. Okay. The time to form, well, that's up to debate. There's actually different types of fossils, different processes, but we just put millions of years. All right, so we have some changes to the earth, slow changes to the earth here. Okay, we've got some pictures, and it wants us to identify what is the process that is going on in these pictures. Okay. And we have what is the process that breaks it down. Well, we'll call this weathering. Okay, I'm looking at some of these processes here to figure out what it is here. I'll be honest with the drawings here. They're not very detailed. It could be left for interpretation, but the words here is what helps me identify which one goes where. Okay. So something's going to move it. Okay. We will call that the erosion. And if it drops it, it leaves it there. Well, this is the deposition. Deposition. All right. Moving on. Skip back over here. Fossil fuels. Fossil fuels. This is an alternative to what we would now consider, or not an alternative, an opposite, a different category from alternative energy. Alternative energies typically now are renewable energies. Fossil fuels, on the other hand, are non-renewable. Even though it is sorry about that, it looks very messy. Even though that they are made from natural processes, from things once alive, the time frame is so long that we call this non-renewable. So we have coal is a solid, okay, and it's what we think it's formed from swamp lands being covered up and it decaying. Oil is a fossil fuel that is in liquid form. And our beliefs on this is that it was possibly the dead sea life. Okay, that would include the animals and the plants in the sea. Natural gas, another type of fossil fuel. And the natural gas, again, we think this is dead sea life. Exposed to extreme heat. All right, finishing up this last little section here, fast changes to the earth. What are some of the processes that can drastically change the surface of the earth? Well, we have volcanoes that can be dramatic. Krakatoa, Mount Vesuvius rapidly change their environment. We can have an earthquake. And I know I'm going a little fast. I see my time is taking too long. I'm trying to speed up. Remember, you're going to be graded on some neatness. So do your very best. And then we have this last one. Again, this picture is tough to see, but what we have is precipitation falling more than what the land can handle. The weight and gravity cause the hill to come down. We call this a landslide. All right, well, I hope this helped you out. Remember, do your work. You'll get a good grade, and hopefully you will learn something in the process. take a look for the other 3 sections and get 100 on this test project.